In this video, we're going to continue to look at measures of central tendency. Calculator instructions in this video are for the TI-nSpire series of calculator. In our last video, we focused on finding the measures of central tendency for discrete ungrouped data. Today, we're going to focus on grouped data and continuous data. We'll begin by revisiting a frequency table that we've used before. The mode is always easy to identify from a frequency table as we just find the data value that has the highest frequency. In this instance, that would be 2, which has a frequency of 6. It's important that we remember when we're looking at a frequency table that we've actually consolidated down a much larger data set into a more compact form. Oftentimes, the biggest mistake students will make when finding the average of grouped data is they'll only take the data values and average them without accounting for how frequently they occur. When we calculate the mean of grouped data, we need to make sure that we're multiplying the data values by the frequencies and dividing by the sum of the frequencies to properly determine our average. In order to accomplish this, I'm going to add an extra column to my table here, one that allows me to multiply the frequency of the data value with the data value itself. I've also added an extra row at the bottom to account for the totals of these values, as I will need that for my grouped average. If I determine the total frequency here first, I'll actually be able to find the median as the next of my measures of central tendency. I've identified that the total number of data values is 25. The median data value in this list will be in position 13, because there will be 12 values below and 12 values above, making it land squarely in the middle. To determine which of these data values corresponds with that 13th position, I'll need to do a running total, or a cumulative frequency. I have 2 data values in my first row. In the first 2 rows, I have 8 in total. Adding in the third row brings me up to 9. Adding in the fourth row brings me up to a total of 12 values. What this means is that the 13th value must be in the next group, which is corresponding to the data value of 5. So I can now conclude that my median value of this data set is 5. Now I'm going to start multiplying the frequencies by the data values so that I can start to determine my mean value. This column is very quick to populate as it's not computationally difficult. Now that I have the total of the products of the frequency and the data values, I can use that to find my grouped mean. Earlier I gave this equation for finding the mean of grouped data. My numerator I found in the table is 126 and the denominator, the sum of the frequencies, is 25. If I calculate the mean from that, I get a mean of 5.04. Of course, doing this process by hand is very time-consuming, especially if the data set is sufficiently large. So again, we're going to want to leverage the power of technology to help us calculate these values faster. We'll transition over to a different data set in order to learn how to find these measures on our calculator. In this scenario, I've simulated some data for Franny's Restaurant and Bakery, which is just down the street from the school. We're assuming here that they track data on the size of each party that dines in the restaurant on a Saturday evening. And they collected the following data over the span of several months. The size of the party is indicated in the table, so that's how many people are seated at a table. And I've also listed the frequency, so how often a party of that size came into the restaurant. From this data, it would not be unreasonable for us to find all 3 measures of central tendency and use that to have a judgment of the average party size that comes to the restaurant. The mode is easy enough to find by inspection of the table. We can see that the size of the party that has the highest frequency is 7. To calculate our mean and median values, we should get out our calculators and let them do the heavy lifting for us. First, we're going to need to press the menu button and add a new list and spreadsheet tab to our document or scratch pad. I'm going to add headers to each of the columns that correspond to the data that we're looking at. Remember to try to keep the column headers short and clear. Our next step is going to be to populate this table with the data that we've been provided with. So I'm going to add in the size of the party and the frequency and make sure that the rows correspond correctly. We're now ready to calculate, so let's navigate to our one variable statistics calculation through our menus. When prompted, we'll need to enter in the party size as our X list and our frequency list for frequency. The calculator will paste all your one variable statistics directly into the spreadsheet with the mean at the top and the median further down the list. From this, we're able to determine that the mean party size is 5.35 and the median party size is 5.5. Now, it would be fair to say in this instance that it's kind of absurd that our mean and median values are not discrete when our data sets are. And we need to recognize that when we look at those averages, that's not a fixed number of people that it represents. The mean, median, and mode taken together gives us a clearer picture of the average party size that's coming into the restaurant. So we can see from this that we are getting a lot of parties of 7 coming into the restaurant. But based on the mean and median being lower than the mode, we can also see that there's a high concentration of data values in that 2 to 5 range, so that's less than the median, where there are parties of that size coming in fairly often as well. If you were the manager at Franny's, you might want to use this data to decide how you do your table layouts in your dining space to properly accommodate the size of these parties and make sure that you have the flexibility to accommodate these numbers. Now we're going to move on to consider how we would do this with continuous data, which poses its own set of challenges because we don't actually have one data value that corresponds with the frequencies in our frequency table. Consider again some simulated data, this time from a dog breeder that breeds Portuguese water dogs. At the age of 1, we're assuming that the dogs are brought in as part of a routine checkup and they are weighed, and then the weights are recorded, and that's how we got the data in this frequency table. The modal interval is easy enough to identify here. The highest frequency seems to correspond to the class of dogs that falls between 19 kilograms and 21 kilograms in weight. The median could also be determined by inspection of the frequency table, but the mean is going to require a little bit of outside-the-box thinking. See, when we have a range of data values, it's hard for us to put one specific data value into a calculator to crunch out the mean really quickly. So the strategy we use to estimate here is we have to recognize that within each interval, the data is likely distributed pretty evenly throughout. We've probably got some low values in each interval, some high values, and some in the middle. And it's probably a symmetric and even distribution of data values. And so, as an estimate, we tend to go for the midpoint of the interval and use that as the data value in our calculation. Again, it won't be a perfectly exact calculation, it is an estimate, but it's likely to be a fairly accurate one. So I've added a column to my table for the midpoint, and I'm just going to calculate the midpoint of each interval and input that data here. Now that I have the midpoint values, I can input this data into my calculator and determine my measures of central tendency in the same way I did for grouped data. So again, I'll want to open up a list and spreadsheet tab in my document or Scratchpad, and I'm going to add column headers that are meaningful based on the data set, and then populate the table with the data that we have, using the midpoint as the data value for the weights, and then entering in the frequency that corresponds to it as normal. Again, it's really important to note that nothing about our strategy has changed here. We've entered in the data, we've navigated to one variable statistics, we're going to enter in the appropriate lists so that it references the data and the frequency, and then calculate to get our list that contains the mean and the median. The main distinction with continuous data is how you prepare it before you go to estimate your measures of central tendency, as opposed to the actual steps that get us there. Based on our calculations, we were able to determine that the mean weight of a dog is 21 kilograms and the median weight was 20 kilograms. Now again, these are just estimates from the continuous data that we've collected, but they're reasonably accurate estimates and we would trust them to have a general sense of the center of the data. Our final exercise for this class is going to be to look at some COVID-19 data from Waterloo Region. As of May 5th, the breakdown of positive COVID-19 tests based on age in Waterloo Region was consistent with the table below. So you can see I've got these age brackets in my left column and a frequency list in the right column. And we're going to work towards coming up with the mean, median, and mode of this data set. As is often the case when we're presented with a frequency table, we can very easily see the mode is the 80 plus age bracket. This might not be terribly surprising. Many of you may look at this data and say, well, we know that that's an age bracket that's more susceptible, and therefore it makes sense that the frequency of cases there is higher. But in reality, that's an observation we made initially because we looked at data like this and could see that the virus would be impacting people of a certain age more readily than others. It is also worth pointing out that this data does not disseminate between those who have mild or serious symptoms. These are only people who have done tests and tested positive for COVID-19. We'll circle back to that point after we've calculated the mean and the median of the data set. In order to analyze the data set, we're going to need to set those age brackets to actually correspond to ranges of values, as we've seen in previous examples. So I've changed the 19 and under age bracket to be 0 to 19. As we know, 0 is a natural lower bound for age. The 80 plus age bracket is a little bit harder for us to define a clear upper bound because we don't actually know any demographic data for Waterloo Region that would inform how old the oldest citizen happens to be. For the purposes of estimating, I have just changed that to an 80 to 100 age bracket. I've added a midpoint column as well that I'll populate with the appropriate midpoints. In previous examples when looking at continuous data, the class intervals have always had the same width. In this instance, that's not the case because of our age brackets on the lower and upper end of the whole age range. If we look at the widths of those other intervals, you'll see that the width of the first range is actually 20 and the last range is 21, whereas the standard class interval width is 10. Now this is going to skew our estimation somewhat unless we account for it. So I'm going to show you a strategy to do that. Full disclosure though, in the SL Mathematics syllabus of the IB, you'll only ever be assessed on fixed class intervals. So most of the examples that you're going to see in your textbooks or in other scenarios throughout the course will not involve this strategy. The reality of the situation is actual data from the real world is always a little bit less elegant than exercises from a textbook. And so we do need to have strategies that allow us to work around those issues. Thankfully, the strategy we use is very simple. It just involves coming up with an adjusted frequency. For all the class intervals that already have a width of 10, we don't actually need to adjust anything. But for the other ones, we can find out how to adjust them by taking their frequency, dividing them by the current class interval width, and multiplying it by the desired class interval width, which is 10. So you can see in the first row, I took the frequency of 10, divided it by 20, and then multiplied it by the desired width of the class interval, which was 10, and that gave me an adjusted frequency of 5. I did the same thing with the 80 plus age bracket to make sure I could get an adjusted frequency there. Now this is really the only step I need to do before I can go and enter this data into my calculator. When I do enter it into the calculator, I will want to make sure I'm using the midpoint as my data value and my adjusted frequency column as the frequency in my calculation. Once again, the strategy we're using on our calculator is fundamentally unchanged from the grouped and continuous example we've done previously. So the key distinction is always that we're setting up our data effectively before we begin entering it into our calculator. Once we've done that initial logical setup and we have the data the way we need it, it's just a matter of using the same tools at our disposal to find our one variable statistics each time. That will allow us to always consistently calculate the mean and the median from the data sets that we are presented with. So we've determined that the mean age of a patient in Waterloo Region who has tested positive for COVID-19 is 53, and the median age is 54.5. Now, we've already established that the mode is that 80 plus age bracket, which is true. There's a very high concentration of people there who have tested positive for COVID-19. But we can see that the fact that the mean and median skew a little bit lower suggests that obviously the center of the data is not quite fixated on that highest age bracket. Now, as far as what conclusions we can reach from this data, you want to be careful not to over-conclude based on our findings. The information that we found here can give us a sense not necessarily of who's most susceptible, although there is potential for that, but in reality all we're seeing is information about who is most likely to be tested and also test positive for COVID-19. So this doesn't necessarily give us the full picture because we don't necessarily know that this is from a fully representative sample. There may be people from within those age groups who do have COVID-19, but because they're asymptomatic, have not gone in for a test and are not featured in our data set. So this is, again, one of those situations where you always want to be very wary about the conclusions you make with statistics, because some people will take the opportunity to calculate a number and then conclude a great many things that are not mathematically justified. So this gives us a sense of how the data is distributed overall. We know kind of the rough center of the data. We were able to estimate that. But beyond that, making too broad or sweeping a conclusion would be a little perilous or reckless in this situation. Now that you've seen how to determine those measures of central tendency using your calculator for group data and continuous data, you're well equipped to actually determine those measures of central tendency for a variety of different scenarios. As we continue to explore how we analyze data of one variable, we're going to look at what happens on the extremes of a data set and focus on measures of dispersion.